Hello, we are going to talk about new Alpaca Linux. Linux is a funny name, and uh, I'm Dmitry Chuyko, and I work at BellSoft. And you know, BellSoft releases and supports libc JDK, and BellSoft actively participates in OpenJDK community. And if you look at the latest LTS OpenJDK releases, JDK 11 and JDK 17, here's our contribution to that releases. And between JDK 11 and JDK 17, in particular, there was JDK 16. And in JDK 16, one of JEPs delivered was support for Alpine musl Linux, integration of Project Portola into OpenJDK mainline delivered by BellSoft. And this functionality allows to build very tiny containers or other kinds of environments with Alpine Linux and JDK. And if you look at libc containers, for example, you'll see that although the wire, this tiniest container, the full JDK, it takes slightly over 70 megabytes, which is really useful when we do pulls for such container images. This will reduce network traffic and pull time during the deployment. So if you remember that Alpine Linux is an interesting beast containing musl, C library implementation, and BusyBox with Army knife tool that mimics all Unix tools. And also there is some lightweight initialization system and the good process of development, including the way binaries are assembled, like they include protection out of the box. And there are some things that the thing are missing in Alpine Linux. It is great, but we offer LTS releases for the JDK. How about having LTS releases also for the OS part of the container where we have Linux and JDK, right? Also, it would be great to have them natively compatible in terms of repositories and other things. Then we install JDK as a package, or it would be great to install native image tool or GraalVM. Also, when we work with musl, it's not very noticeable, but there are cases where performance plays a role, and there is a difference when we use musl C library implementation. Another useful things that are missing would be support for different clouds and easier migration for legacy applications that depend on libc implementation. Ourselves, yes, we're actively involved in using different Linux distributions, because libc is a distribution of OpenJDK with the most number of supported platforms, I mean CPU and OS configurations. So we support multiple flavors of Linux distros in containers and multiple package manager systems. We know that core system libraries are critical for performance of your final Java workloads. And BellSoft has a team of engineers who previously worked on Oracle Enterprise Linux. And we participate also in Linux development. Some issues come from OpenJDK support and OpenJDK development, like musl port. That's also true for GraalVM project. So we have such great forces, and we have great wishes. It's so obvious that now we have our own Linux distro. Welcome, Alpaca Linux. This is a Linux distribution supported by BellSoft, and it includes, of course, Liberica JDK and Liberica native image kit. And the distribution is focused to deliver a great experience, different infrastructures, to provide you best performance and to be secure. So once again, we will talk about security features, performance optimizations, how small this Linux is, because it is somehow special again. And of course, it all mentions, and please keep in mind, that Liberica JDK and Liberica native image kit are first-class citizens in this Linux distribution. Then we have this. We get container-friendly environment. We build our own infrastructures or pipelines easily. And we unify development across different platforms. So let's get back to the internals of Alpaca Linux. Yes, it is a new Linux distro. We decided that existing Linux distributions do not simultaneously provide the desired list of features for being a Linux distro, great for Java workloads and clouds. So these features include, of course, long-term supported releases, the out-of-the-box JDK and the native image tooling, security management, and others. So we decided to create a new one, as I mentioned. And the philosophy behind that is very simple. We are very close to Alpine Linux. That's why I started with mentioning Alpine Linux and Alpine Linux support of OpenJDK. And all the work that we do and all the work that we are going to do, as well as in OpenJDK community, we're trying to contribute for everyone, in this case in Alpine Linux, or to keep publicly available as an open source. And we also track licenses of all the components that we include and support in this distribution. So having that, we provide long-term support releases aligned with Alpine Linux releases, and the long-term support is aligned with this period is aligned the period of long-term support for Linux kernel, and we include LTS kernel versions in the case then we work to the system with the kernel. So current version that we present now is 3.14, aligned with the version of Alpaca Linux, but it is based on kernel 5.10, and it includes security features, as I said, performance optimizations in both in kernel and user space. We'll look at them a bit later. Docker and QEMU support. And this system is already optimized for Liberica Lite and Liberica Native Image Kit. It is available, of course, as an ISO file, and this system works with its own repository of APK packages. There are also Docker Hub container images, of course, for the JDK, for Liberica Native Image Kit, and also for basic tools like compilers and Python. There are also trusted Docker registry where extended LTS binaries are going to live. And there are virtual machine images in work for all major clouds. If you look at the components, there are slight differences between Alpaca and Alpine, and of course larger differences if we compare to other larger Linuxes. The standard C library, it may be also glibc for Alpaca as an option. Musl has two flavors, and it has slightly different version. Two flavors are basic one and special perf one. We'll look at some numeric results later. And of course, JDK and Native Image Kit included are Liberica JDK and Liberica Native Image Kit. So let's talk about security first. How security is enhanced in Alpaca Linux. On multiple fronts, like kernel protection, where we select options that we believe are better in generic for cloud environments, like disabling insecure modules in particular. And then we protect user space in a way, well, similar to what Alpine does. So we provide secure compilation options, and we also limit the number of components available, like there is no GUI, for example. So in the end, it is a lower attack surface. And the important component is managing the security, managing threats. So how do I address CVEs? Of course, like many other distros, we pull fixes from the upstream quickly within 1 day SLA. And for OpenJDK and GraalVM security issues, we are in line with update cadence of OpenJDK and GraalVM quarterly releases, which are then propagated to Alpaca Linux. Moreover, CVEs are managed through security advisory being created. Security advisory for Linux and for OpenJDK, and all that is supported by tooling like scanners and databases that we are going to announce as well. So then let's proceed to optimized performance. Yes, Alpaca Linux is optimized for different workloads. First, we believe that it may be not so unusual to have demo machines like in cloud, or it's like some server hardware, and all that require or may be improved with some specialization of Linux kernel, which is done in Alpaca Linux. And as I mentioned, there is a special optimized version of musl C library implementation. How it's different from the version that's included in Alpine Linux out of the box? Well, in Alpine, it's optimized for size, and we decided to provide version optimized for speed that includes parts compiled with more aggressive compilation options and function specializations for great architecture extensions available on specific hardware platforms. So what it gives us? Let's look at some workloads. If we compare default musl implementation, optimized Alpaca musl perf, and glibc in some, for example, string benchmarks, we'll see that it really helps much, and we get clearly better results than this optimized library. Another topic might be using different malloc implementation. It is widely adopted in large-scale services, and we included a few additional allocator implementations in Alpaca Linux that may be easily installed through the package manager and easily used, like in the example shown here. How does that matter? Well, different malloc implementations work best for different kinds of workloads, so you can experiment. Here are a few tests with different mallocs involved, and you see that the gain that we have by switching malloc implementation may be really huge, maybe even times or an order of magnitude. So these are some native workloads. Here are some more. If we look at classical CPU benchmarks like specint and specfp, optimized musl implementation helps as well. You see then we compare Alpaca, regular Alpine, and glibc based systems. We see that sometimes optimized Alpaca implementation may even outperform glibc versions, or sometimes they are on par and it's better than regular non-optimized version of musl included in stock Alpine. And then we get finally to Java workloads. You see famous Da Capo benchmark is really happy then the system provides such optimized libc implementation. And this is a benchmark, a number of benchmarks that may be considered like micro benchmarks, but what if we try to build some application that we are used to? Of course, I'm talking about using some microservice for testing. Well, as you may know, libc JDK is the default runtime for container images of Spring Boot. So here we have Spring Boot application running on different systems. So I'll explain the setup a little bit. So the hardware here is relatively low end, but there are multiple systems installed on the same hardware on bare metal. Oracle Linux and OpenJDK, stock OpenJDK 11 in that Oracle Linux, Debian 10, and again stock build there. Alpaca and Liberica Lite optimized combination, and also Alpaca and Liberica native image kit, where this Spring Boot Pet Clinic application is assembled via Spring Native into native image. And what do we measure here? So we put relatively low load, which is below the maximum load, and the machine is underutilized in terms of CPU. And we put it not instantly. We let the application to start, of course. Then we let it to calm down for some time. And then they put some low load. That is not so uncommon situation in wild. And what we are going to see here? Well, we see how optimized distro and optimized JDK helps to save footprint. You see there's a huge gap in memory size consumed by the application. Even though we have some load here, it's not just started and not used service. We have savings mostly because of additional functionality in garbage collector that gives memory back to the operating system, and also the footprint of the JDK itself, and of course system optimization. And if you look at the latency from the start, including all the problem points and all the quirks of the measurement way applied here, we'll see that we also can catch improvement in this area by using Alpaca and Liberica JDK Lite. And there is a great difference where native image kit helps us to reduce latency because it provides us low latency from the start. In particular, then we try to study the details. The picture will be more interesting. You see on the left picture, the line in the middle is how tiered compilation in hotspot makes your code more performant all the time. So if you take the same application but more powerful hardware and try to really figure out what's the throughput and latency of the warmed-up application is, well, you first observe the warm-up itself, how the actual maximum rate that the application can handle raises. And by the way, for native image, it is instantly the maximum. And then we compare warmed-up application and when behavior, and then we look at latencies. The difference won't be so huge. Like at previous slide, it was almost 50 times. But here still native image can give us better latency for this small service and this particular scenario. But it's like 2x better than hotspot. So that's performance, and don't forget about Alpaca Linux being very, very small. It's less than 3 megabytes in size. And as I mentioned, we can combine Alpaca and native image kit and native image. So we can get applications that start very fast. The start of Linux, so if we talk about full virtual machine, is noticeably better than, for example, Debian. And if we at start of the application compile to native image, it will be almost instant. Then we compare it to start of application with classical JVM. And we get all that in very slim Docker images, which is really effective for massive cloud deployments and massive updates. So what did we see today? We met new Alpaca Linux, which is ready for use. It is small, less than 3 megabytes. It is performant. We have great performance results for native workloads, for Java workloads, because of optimized musl C library, because of optimized Java version. It all combined and tested together, and it is secure because of CV tracking and the process of building the binaries in both kernel and user space. Of course, that's for current version, but we are going to have next versions where we continue to optimize both Linux part and JDK and native image kit parts. Currently, we provide only x86 64 containers and ISO assemblies, but next platform to support, of course, it's ARM64, where we'll see all the same optimizations playing role. And then next things critical for native images in the cloud, like for example having low pos collector or optimizations for other languages, not just Java. Remember, Alpaca Linux 3.14 is available now, and it contains all the enhancements that we saw today. You can get it if you contact us or request a demo. Please follow the links or ask your questions in Q&A. Thank you very much.